Hi, I am Javier Alejandro Diaz and I'm going to talk about the mobile network generations. So first of all, we need to talk about the signaling process. Well, a cell phone offers full duplex communication and transfer the link when the user moves from one cell to another. As the phone user moves from one cell area to another, the system automatically commands the mobile phone and a cell site with a stronger signal to switch on to a new frequency in order to keep the link. The cellular system is the division of an area into small cells. This allows extensive frequency reuse across that area so that many people can use cell phones simultaneously. An available frequency spectrum is divided into discrete channels, which are assigned in groups to geographical cells that cover a service area. The discrete channels can be reused in different cells with diameters ranging from 2 to 50 kilometers, and the service area is assigned to the radio frequency transmitter, while the adjacent cells operate at different frequencies to avoid interference. The first generation, the analog cellular networks, was introduced in the late 70s, and the first cellular systems were analog voice. Obviously, it uses analog signals. Was based in the AMPS technology. It allows voice calls in a single country, and the first commercially automated cellular network was launched in Japan by NTT in 1979. Also in 1984, Bell Labs developed modern commercial cellular technology, which employed multiple centrally controlled base stations, each providing service to a small area, and the cell sites will be set up such cells partially overlaid. And the second generation, digital networks, it refers to the digital voice systems of the 90s, replacing analog phones and based on the TDMA and CDMA interfaces. The first deployed in Europe was the GSM, became the predominant TDMA-based cellular system worldwide. Introduced a new variant to communication, the SMS text messaging, and the digital signals require consume less battery power, so it helps mobile batteries to last long. Digital coding improves the voice clarity and reduces noise in the line. The 2.5 generation, well, this technology is a cellular wireless technology developed in between its predecessor, the 2G, and its successor, the 3G. The GPRS could provide data rates from 56 kilobits per second up to 115 kilobits per second. It can be used for services such as wireless application protocol access, the multimedia messaging service, and for internet communication services such as email and worldwide web access. The third generation, 3G high-speed IP data networks, it uses packet switching rather than circuit switching for data transmission. Was the first mobile broadband. The downstream speeds up to 1 megabit per second and more depending on the 3G version. The predominant 3G technologies on the GSM side are WCDMA and HSDPA, with CDMA 2000 on the CDMA side. Further speed increases are available with HSPA Plus, which provides speeds of up to 42 megabit per second downlink and 84 megabit per second with release 9 of the 3GPP standards. And 3G also embraces worldwide roaming for global travelers. The fourth generation 4G growth of mobile broadband, well, starting in the 2011 timeframe, GSM and CDMA carriers embrace LTE, which offers higher speeds than 3G networks. LTE embodies the design goals of the IP Multimedia Subsystem (IMS), which integrates all communications using the IP protocol for voice, video, email, web messaging, and other services. In this generation, they eliminates the circuit switching, instead employing on all IP network. Thus, 4G used in a treatment of voice calls just like any other type of streaming audio media, utilizing packet switching over Internet, LAN, or WAN networks via voice over IP. The 4G LTE data transfer speed can reach peak download 100 megabit per second, peak upload 50 megabit per second, and WiMAX offers peak data rates of 128 megabit per second downlink and 56 megabits per second uplink. And finally, the 5 generations, that is, instead of develop it transfer rates of tens of megabits per second for tens of miles of simultaneous users, transfer rates of 100 megabits per second for metropolitan areas, has several hundred miles of simultaneous connections per antenna. Spectral efficiency improved significantly compared to the 4G, improved coverage compared to the 4G, has a greater signaling efficiency, and latency reduced significantly compared to LTE, has a higher quality of service. There is a new radio standard for the 5 generation that separates from LTE. This is the 3GPP standard, and multiple input, multiple output, what it's called MIMO, will offer significant gains in wireless data rates and link reliability.